How might we fix it? Well, here's a nice, simple idea that will fix this. I'm going to do it just on depth first. The same thing would apply to breadth first. I'm going to do the same thing as I did before. The changes are the following. I'm going to add an internal variable called seen. It's going to be a list that keeps track of what nodes have I already looked at. I'm going to run as I did before, going through all of these things. But right here, when I get to a new node that I'm looking at, I'm going to add it to the list. Simply append it at the end of the list. And then, when I want to say, do I want to explore below this node or not, before I go ahead and add a right branch, I'm going to check to make sure I haven't already looked at it. If I haven't looked at it, I add it in. Same thing with the left branch. That simple change works. And if I go, in fact, back over here, I've written a piece of code, that piece of code right there, and I go over and I do depth first search binary with no loop on N5 and find 6. It does exactly what I'd expect. And if I do the same thing, but with find 10, it also does it. So what was the point of this? In this lecture, we've seen trees, great data structure. We've seen depth first and breadth first search on it. We've seen how we use that to help make decisions in optimization problems, and we'll come back to that in the second half of the course. And we've already seen a hint of another idea, which we'll use in other places doing search, which is that by keeping track of what we've done, keeping track of where we've been, we're able to avoid causing infinite loops in search problems in structures that might, in fact, have loops within the structure themselves. And that gives you a great sense of trees.